Did you know that every year, 5 to 10% of your skeleton is replaced? That means that our whole skeleton is replaced about every 10 years. Bone tissue, made of cells called osteoblasts, osteocytes, and osteoclasts, all surrounded by calcium salts, is actually quite dynamic. This is important since when bone remains in place for extended periods of time, calcium salts crystallize, which makes bone more brittle and prone to fracture. The process of degrading and remaking bone is called bone remodeling. To understand more about this process, let's meet our main characters. Our osteoclasts are our bone breakers. Interestingly, they come from the same lineage as our macrophages, a type of white blood cell. Osteoclasts secrete acid and enzymes that break down bone. Our osteoblasts are our bone makers. They secrete new bone matrix that later calcifies into the hard bone that we all know and love. Our osteocytes work to maintain bone tissue. But how is this regulated? This complex process doesn't just happen willy-nilly. Bone remodeling is governed by two factors: maintaining appropriate calcium ion concentrations and maintaining bone strength. Our cells are surrounded by extracellular fluid, which is kind of like a soup of nutrients and ions. One of the ions present is calcium, which plays a very important role in nervous function and muscle contraction. Calcium ion concentrations are monitored by your parathyroid gland and a hormone aptly named parathyroid hormone, or PTH. Low levels of calcium ion cause your parathyroid gland to secrete PTH, which increases osteoclast activity, causing calcium ion levels to rise. Bone strength is maintained through a concept known as Wolff's law, which states that bone will grow based on the stress that it is subjected to. Bone tends to be thicker and stronger in areas that are subjected to the most force. When a force is exerted on bone, the bone deforms, and this is ultimately sensed by osteocytes, which encourage osteoblasts to form more bone matrix at that location. We can think of hormonal controls by PTH and the parathyroid gland as dictating when bone remodeling occurs, and mechanical controls by forces as dictating where it occurs. When calcium ion levels are low, that's when remodeling occurs, and the areas of bone that are subjected to the least stress are degraded first, while areas of bone that are subjected to more stress are where bone is rebuilt.